Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney Civvy, and this week I've titled the podcast A CFM is a CFM. It's actually a continuation of last week's standard air versus actual air podcast. I was going to move on to fans and water coils at altitude or high temperatures, but I wanted to make sure we're all on the same page with air density and CFM. So air is all around us, and we walk through it all the times, and sometimes we forget it's actually a thing. It's a fluid with mass and is made of particles. So I wanted to start with something a little more tangible. So I remember when I was a kid, there was a riddle that asked which is heavier, 5 pounds of rocks or 5 pounds of feathers. And when you're a kid, you think, well, rocks are heavier than feathers, so 5 pounds of rocks would be heavier, but obviously a pound is a pound, so they weigh the same. But a pound of rocks may look something like this, and a pound of feathers might look something like this. So let's cross out verses and say 5 pounds of rocks equals 5 pounds of feathers. So much like a pound is a pound, a CFM is a CFM. Let's say we put this section of rocks in a 1 foot by 1 foot by 1 foot, also known as a cubic foot box. Let's say it pretty much holds all those rocks. And we do the same with a section of feathers over here. So it's 1 foot on each side. Okay, so over here we have a cubic foot of rocks, and over here a cubic foot of feathers. If we moved it down ductwork at the right rate, we would have 1 CFM of rocks and 1 CFM of feathers. So now we have our cubic foot of rocks and a cubic foot of feathers, but you can clearly tell they have different weights. Let's say a cubic foot of rock weighs 5 pounds and a cubic foot of feathers weigh a ½ pound. So now we're talking about the density. I need a little room here. Density equals mass divided by volume. So without even doing the calculation, you can see that 5 pound cube of rocks is more dense than the ½ pound cube of feathers. So it has a higher density. So it seems obvious if you were trying to pick up this box of rocks, it would be harder to move than if you tried to pick up the box of feathers. You can also imagine that the rocks would hold more heat than the feathers. So maybe rocks and feathers are not a really good thermal analogy here, but you kind of get the point. This is basically how altitude and temperature affect HVAC systems when they reduce the density of the air. So let's get back to air now. A CFM is a CFM. So if we draw the United States, and let me pause for a minute and say that I'm sure you're shocked that I can draw the United States but not a pile of feathers. So I'm going to have to say that I totally traced this. My first 2 attempts kind of looked like happy cartoon fish. Okay, so say I was in Dallas, which is where I am actually, and I cut a 1 by 1 by 1 foot cube of air out in front of me. And then someone does the same up in Denver. So they're the same size, 1 cubic foot of air. And if it moved down the ductwork again at the right speed, it could be a 1 CFM of air. Because I'm at a lower altitude, my cubic foot of air is denser. It just has more stuff in it, more molecules of air. And up in Denver, you can see they'll have less molecules of air. So the more molecules of air there are in my cubic foot, the more I have to interact with heating coils, cooling coils, fans, and other stuff in your HVAC system. So the lower the density, which is typically caused by high temperature or high altitude, the lower the horsepower needed to move the air, and the lower the heat transferability of the air. So lower temperatures or lower altitudes have higher density air, and this means that you need more horsepower to move the air, but it has a higher heat transferability. So next week we'll look at how density, typically altitude, affects water coils and fans. So we'll get back into air and HVAC again and leave our rocks and feathers. So don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.